This question's from the New Zealand Institute of Physics Level 2 Mechanics paper from 2019. So we've got a dinghy that's being stored out of water, supported by two struts, each at 45 degrees from vertical, and we're asked to draw a labeled force diagram to show what's going on here. So I'll start with the left-hand support force, and we've also got a similar one on the right-hand side there. Then we would have the weight force acting straight downwards. To draw our force diagram, we're then going to take those vectors and join them nose to tail. And since the dinghy isn't accelerating, we know it's not acted upon by an unbalanced force, which means that when we join those vectors nose to tail, they should all join back onto the starting position. I'll show you what I mean by that in a moment, but it doesn't matter which order you draw them in, they should always come back to whichever one you started with. So if we take the weight vector out and draw it separately, making sure we label it, and then we can take either of the support vectors, but I'll take what I've called support 2, and joining them nose to tail, and there's our support force 1 as well. And so that's our force diagram showing what's going on in this situation. For the next question, we're asked to calculate the size of the support force from one of the supports. So if we draw that support force separately here, we can turn that into a right-angled triangle, and we know that the vertical component of that support force, so represented by the green dotted line or dashed line, will account for 1/2 of the weight of the dinghy, the other half of the weight of the dinghy being supported by the other support force. So the mass of the dinghy is 1,500 kilograms, multiply that by 9.8 to turn it into weight, newtons, and then we can divide that by 2 to get 7,350 newtons. So we know that that green dashed line for one of the supports, the vertical component, is 7,350 newtons. Then trigonometry is going to allow us to work out the magnitude of support force 1 here. So we can use SOHCAHTOA, and based on the angle that's drawn here, we should know that we're looking at the opposite and the hypotenuse. And so I've color-coded those just for your reference. That gives us sine 45 is equal to the opposite divided by the hypotenuse, which we can rearrange and substitute in values to give us this equation here. And then punching that in on your calculator should give you an answer of 10,394 newtons, which we would round to 2 significant figures, since the lowest number of significant figures in the question that we've been given was 2 significant figures.